Welcome back to Topic 3 for Algebra 1, Solving Linear Equations. In Part 2, we're going to practice solving multi-step equations, or with variables on both sides of the equal sign. Just like we did in Part 1, I'm going to provide a few helpful steps that will help guide you when solving multi-step equations. First, I think it's optional, but also really important and can provide a really helpful visual tool to draw a line vertically through the equal sign to separate the right side from the left side. Once you have done that, then look to see if you need to distribute on each side of the equation. Not all problems will include the distributive property, but some might, and if you see it, I recommend doing that as the second step. Then what we'll look to do is to combine like terms on each side of the equation. Once we've combined like terms, so either our variable terms or our constant terms, then we're going to move the variable to one side of the equation, and then move our constant to the other side. By doing this, we're going to undo addition and subtraction, and then undo multiplication or division, just like we did when solving a two-step equation. Finally, we're going to plug our variable back in to check our work. With our first example, we have 13 plus 5x equals 2x minus 8. So I'm going to first start by drawing my vertical line, or semi-vertical, I should say. Since we have no parentheses that we see, there's no need to distribute in this example. But we can combine our like terms by moving the variable to one side of the equation. If we look on the left-hand side, we see 13 and 5x. Now those are not like terms, so we cannot combine them. On the right-hand side, we have 2x and negative 8. Those are also not like terms, so we cannot combine them. But we can decide which side of the equation we want our variable to sit, since we have a variable both on the left-hand side and the right-hand side. For the sake of this problem, I'm going to say we'll move our variable so that it sits on the left-hand side. So we'll have our x on the left-hand side, and our goal is to have all of our numbers on the right-hand side. In order to do this, to get our x solely on the left-hand side, we have 2x on the right-hand side. Now this is actually a positive 2x, even though we don't see a positive sign in front of it. Whenever you don't see an operation, it's automatically positive. Only when it's negative will it be really prominent and stand out and tell you that it's negative. So in order to undo this addition, we're going to subtract 2x from both sides. And notice how I'm lining it up so that it's lined up vertically with its like terms. That can be really helpful when simplifying. On the left-hand side, we still have our 13 that we're just going to bring on down here. Then we have 5x minus 2x, which gives us a positive 3x. On the right-hand side, 2x minus 2x adds to 0, and we're just left with our negative 8. Now what we have here is actually a two-step equation. Since we want our numbers to be on the right-hand side, I need to move my 13 from the left to the right. Since this is actually a positive 13, the opposite, or I should say the inverse, of addition is subtraction, so I'm going to subtract 13 from both sides. Positive 13 minus 13 adds to 0, and I'm going to bring down my 3x. On the right-hand side, we have negative 13 negative 8 minus 13. So since we have two negatives, our answer is going to be further negative on the number line. So we're going to take these two numbers, 8 and 13, add them, and then bring down that operation, which gives us negative 21. One step to go. 3x equals negative 21. Now, like I said before, in part 1, this is really 3 times x. So the inverse of multiplication is division. We're now going to divide both sides by 3. On the left-hand side, it simplifies to 1x, or just x. I'm going to write it over here. And on the right-hand side, we have negative 21 divided by 3, which gives us negative 7. Now, before we move forward, let's just plug our variable back in to check our work. So we're going to plug this back into the original equation wherever we see an x. So we have 13 plus 5 times negative 7, because remember it's 5x, so there's really a multiplication sign in between the two. This should equal 2 times negative 7 minus 8. On the left-hand side, we can simplify using PEMDAS, so we'll deal with our multiplication first. 5 times negative 7 is negative 35. So on the left-hand side, we have 13 minus 35. This is going to be equal to 2 times negative 7, which is negative 14, then minus 8. On the left-hand side, 13 minus 35 is negative 22. And negative 14 minus 8 is also negative 22. So our equation is balanced, and x equals negative 7 is our final answer. Moving along to number 2, we have 7x plus 2 times the quantity x plus 6 equals 39. Now, I'm a real stickler with my students, how they usually say 2 open parentheses, x plus 6 close parentheses, but really it's 2 times the quantity. That kind of tells you that we're dealing with parentheses here. It's this entire quantity of x plus 6. So make sure we deal with that. First, what I'm going to do is draw my line vertically. A little bit better there. Okay, step number 2 tells us to distribute if we see on each side. Well, we only need to distribute actually on the left-hand side. We have 2 times x and 2 times 6. So I'm going to rewrite the left-hand side of this equation. Bring down that 7x plus 2 times x is 2x, and 2 times 6 is positive 12. That's going to equal 39. Now, I need to combine some like terms. Since we have 7x and 2x, they both have the same variable raised to the same power. They are like terms. 7x plus 2x gives us 9x. Bring down my 12, and that's equal to 39. So all we're left with here is a two-step equation like we dealt with in part 1. Since we see addition with our positive 12, we're going to subtract 12 from both sides and simplify. 12 minus 12 adds to 0. We'll bring down our 9x. And 39 minus 12 is positive 27. Now we have 9 times x. The inverse of multiplication is division, so we're going to divide both sides by 9. On the left-hand side, it reduces to 1x, or just x. And on the right-hand side, we have 27 divided by 9 is 3. Now, in order to check our work, let's plug it back into the original equation. Here we have 7 times 3 plus 2 times the quantity of 3 plus 6 equals 39. Now here we can solve in our parentheses first, thinking about PEMDAS. So we can add 3 plus 6, or we can use the distributive property. Let's solve using PEMDAS for here just so we get some more practice. 3 plus 6 adds to 9. Oops. So we'll get 7 times 3 plus 2 times 9 equals 39. Now let's go through and simplify our multiplication. 7 times 3 is 21, plus 2 times 9 is 18. That should give us 39. 21 plus 18 is 39. So our equation is balanced and x equals 3. Moving along to our final example, 3 halves times the quantity of 3x plus 5 equals negative 24. So I'm going to first draw my line vertically through my equal sign to separate the left side from the right hand side. Now, since I notice I can distribute on the left hand side, I'm going to do so. Now, I know you might see a fraction here. You should see a fraction here. Don't get scared. It's okay. Fractions are numbers too. So I'm going to distribute this 3 halves to the 3x as well as to the 5. And I'm just going to rewrite the left-hand side. So this will give me 3 halves times 3x plus 3 halves times 5. And that will equal negative 24. Now I'm going to go back on the left-hand side and make my other numbers into fractions too, so that way it's a little bit easier to simplify. This is really 3 over 1x, and this is also really 5 over 1. Now we can simplify. 3 halves times 3 over 1, we'll deal with the x in one moment. 3 times 3 in the numerator gives me 9. 2 times 1 in the denominator gives me 2, so 9 halves x. Then we have 3 halves times 5 over 1. 3 times 5 is positive 15. 2 times 1 is 2, so we have 9 halves x plus 15 halves on the left-hand side, and that equals negative 24 on the right. Now what we have here is really just a two-step equation. But what I'm going to do is I notice how on the left-hand side I'm dealing with fractions. On the right-hand side, it would also be easier if I dealt with fractions. Notice how the common denominator on the left-hand side is they're both halves, so they're both over 2. Can I rewrite negative 24 so that it's a fraction with a denominator of 2? Let's try. So if I think about it, what number over 2 will give me negative 24? So a number divided by 2 should equal negative 24. Now we're going to deal with this a lot more in topic 5 for Algebra 1, but we could cross multiply. So cross multiply means we're going to multiply the denominator with the numerator of one fraction and the denominator with the numerator of the other. So we get 1 times our mystery number equals 2 times negative 24. When we simplify, we get 1 times our mystery number equals negative 48. Now we can divide both sides by 1 here, and our mystery number is negative 48. So on the right-hand side, negative 24 in a fraction with a denominator of 2 is the same thing as negative 48 halves. This is going to be easier when we solve this two-step equation. So our third wheel for this two-step equation here is clearly our 15 halves. It's the one on the left-hand side that's farthest away from our variable. So we see positive 15 halves. We're going to subtract 15 halves from both sides. See what I mean, how it's easier to simplify now that's in fractions? You may not think at first, but I promise it will get easier. On the left-hand side, it adds to 0, and we're just left with 9 halves x. On the right-hand side, we have negative 48 halves minus 15 halves. Since they have the same signs, we're going to add those numbers and bring down our operation. Now, because they have the same denominator of 2, we're going to keep that denominator and really just focus on the numerator. This is kind of a review of some early pre-algebra. So negative 48 minus 15 gives us negative 63 halves. Now what we have here is a two-step equation. On the left-hand side, we have 9 halves times x equals negative 63 halves. So we can divide, because we see this is really 9 halves times x, both sides by 9 halves. But remember in part 1, if we divide by a fraction, that's the same thing as multiplying by its reciprocal. The reciprocal of 9 halves is just the fraction flipped. So instead of 9 over 2, it's really 2 over 9. And we want to preserve the equality of the equation, so we're going to use the property of equality and do what we do to one side, do it also to the other. If we simplify this, we have a 2 in the numerator and a 2 in the denominator. That reduces to 1. And a 9 in the numerator and a 9 in the denominator. Also reduces to 1. So we're left with 1x, or just x. On the right-hand side, we have negative 63 divided by 2 times 2/9. Notice here how we have a 2 in the numerator and a 2 in the denominator. So what we're really just left with is negative 63 divided by 9. Now we can simplify this, and our final answer is x equals negative 7. Now, in order to make sure our answer makes sense, let's plug our variable back into the original equation to check our work. So we have 3 halves times 3 times negative 7 plus 5 should equal negative 24. Now, if we think about PEMDAS, let's simplify in our parentheses first. We have our 3 times negative 7 plus 5. Looking further, we want to multiply 3 times negative 7, so we have 3 halves times negative 21 plus 5. Further simplifying in our parentheses, negative 21 plus 5 gives us negative 16. So 3 halves times negative 16. I'm going to write this as negative 16 over 1, just so we can simplify our fraction a little bit easier. Now we can multiply straight across. 3 times negative 16 gives us negative 48, and 2 times 1 is 2. Now we learned before that negative 48 divided by 2 gives us negative 24, which equals negative 24. So our equation is balanced, and our answer of x equals negative 7 remains true. That was part 2 for topic 3 of Algebra 1, solving linear equations. Thanks for watching.